Yes, hello. Welcome to our Open Operations meetup today with the topic Open and Transparent Operations with the SCS status page. Welcome and thank you to Sebastian and Joshua for the presentation. Please go ahead.
Thank you. Talking about introductions, a very short introduction. I am Sebastian Kaupe. I am with the SES team over at Gonicus, and I have brought with me my wonderful colleague Joshua Irma, also from Gonicus, of course, who not only wrote our backend implementation and the deployment files, but also provided us with these lovely slides, which I will use to fuel my incessant prattling for your listening pleasure. So let's get the show on the road then, shall we? Open and transparent operations with the SES status page. I'm going to assume that all of you know what a status page is, and just as I'm going to assume that all of you have joined out of your own free will. But just to make sure, very quick reminder, a status page is a web page hosted by usually a company or organization that is displaying the status of something. That something might be a server, a service, something that can experience some kind of outage or problem. And ideally, you would want to have a status page to tell people when this happens. So why exactly? I mean, you can prepare for many problems. You can prepare in case of you are being a company that runs a data center, you can prepare to a certain degree for a power outage. You can prepare for a fire, for hacking attacks. But let's be honest, no matter how well you've prepared, incidents will happen. Something is going to go wrong. A hacker will come through, a fire will get out of control. Your ISP might not be capable of providing service to an acceptable level. Whatever it is, whatever happens, something will occur that will tear your systems down. Your infrastructure, your environment will become incapable of fulfilling its services. And well, what happens then? Well, I mean, ideally, you will of course send your employees to fix the problem rather quickly, if possible. A better question: what will happen on your clients, on your customer side? Well, they are bound to notice at some point that something with their environment they are renting from you, possibly for a quite nice amount of money, isn't quite working as it should be. And so, unless they have a way to get information about what is currently going on, they will probably start asking you. That means they will start calling or writing emails and calls that will go either to your first level support or whatever your support operation looks like. In the worst case, if they have the appropriate numbers, maybe they will reach exactly the same engineers you've just sent out to take care of the problem, which would mean that there would be more delays and it would just get everything would get more expensive, more pressure on your support staff. That is not good. That is not what we want. We want things to conduct themselves in an orderly way, even in case of incidents, of outages, problems, whatever it is that happens. And for exactly that purpose, a status page is a wonderful thing because it enables your customers to to look up by themselves what is currently going on, and maybe you can even keep them informed about what you are currently doing. So no calls to your dear support staff who will probably otherwise get very tired of answering, not of course not asking the very same questions time and time again. So given that status pages are apparently such a beautiful and useful thing, surely there are a whole heap of projects, of ready-made status pages that you can use. And of course, you would be right. There are a whole bunch of them, like this one, or maybe even these two. Or in cases you feel you have too much money in your bank, you can even go to Atlassian and ask them to sell you one. um, so, did we just use one of those? No, we didn't. We built our own. Why? Well, at the beginning of this whole affair, we sat down and had a look at all of these available projects. We even had a nice little, and there are some heavy quotes around that little comparison matrix that was checking each of these available status pages for things that we would want to see in our own status page. Oh, by the way, this orange text is a link, so I think those slides will be made available later on. You can have a look at that and get linked directly to the comparison matrix if you are interested in that. A number of factors went into our decision whether a status page project would be interesting to us or not. Number one, the project health. Is this a healthy project? Is there one or more maintainers that are actively working on the project? Is there a rich community surrounding the project that can take care of problems or provide you with new features, necessary functions, bug fixes, whatever? Ease of use was considered. We want our status page to be easy to use, both as in dropping it into your infrastructure and making use of it by hosting it, but also in developing for it. So ideally, our status page would not be developed with a home-written dialect of Ruby that was made up by somebody in the early 2000s. Features. Now, a whole bunch of these status pages have features that we don't have when taken all together, but none of the status pages managed to just quite hit that feature setup that we wanted to see. Likewise, theming or branding. A status page is a customer-facing website usually, and because it is customer-facing, you would want it to be themed. After all, when the customer looks at your status page, you would want him to be able to recognize that this is your status page and not the status page of or one of 7 status pages of different companies that look all the same. So theming was one thing that we wanted to see, and surprisingly, not every status page supports something like that. Likewise, an API. We wanted our status page to have some kind of interface that we can query or write to, even programmatically, so that we had the option to automate certain things, whether that would be automated reporting of incidents or automated creation of reports, let's say. An API for that would be very useful. And again, this is a feature that is not available in all projects or might be, next point, hidden behind a business model. Some status pages want you to pay money for them to provide you with an API that you can access. And us being an open source project, publicly funded, it's a bit hard to necessarily explain why you absolutely needed to buy this status page just because you wanted a programmatically available API. So overall, in the end, none of the projects that were available quite satisfied us. And so we did what every good developer does when he is faced with a daunting prospect of an untouched software field where bits and bytes are still frolicking freely. We went and did our own implementation because that is what we like to do. Now, before sitting down and starting hacking, we sat down and started to discuss concepts. We wanted our implementation to be guided by a small set of concrete concepts that we can use to build something interesting. Concept number one, our status page should be open. That is, one, open is in open source. As I already said, we are an open source project. We use open source, we provide open source, we love open source. When we build a status page, it should be open source. It should also be open as in easily accessible, easy to approach. We don't want this to be some kind of daunting software project from an ivory tower that makes potential devs tremble at the very thought of getting involved with it. and we wanted it to be replaceable. What do I mean with replaceable? I mean, the entire thing, if monolithic, can always be replaced. But we mean replaceable as in we want parts of it to be replaceable. We don't want this to be a single monolith that you have to either consume or die. You either use this and this and this, or you don't get to use our status page at all. No, we wanted to be a bit more flexible. We wanted to have something where you can take the parts that you like and keep them and throw out everything else and replace it with your own. This, of course, meant that we needed a certain amount of decoupling, apologies, in our implementation to keep this replaceable nature intact. And that, of course, also means that we have interconnected components. The components need to speak to one another, but in a decoupled way. And that requires that all components exchange messages using standardized messages and interfaces. What we arrived at it is this. This is a high-level overview of our architecture. And you can see that our application is split into 4 different layers, which are displayed vertically here. We have at the very left the application layer. This is the part that your user actually interacts with. This might be a web app. This might be a command line client. In fact, as you can see here, we have 2 different example implementations of our concept included in this diagram. The top one is the one we, spoilers, actually implemented. The bottom one is an example for a very different implementation, but we'll get to that in a moment. So, top layer, the application layer, this is where your client-facing stuff lives. Then there is a policy layer. The policy layer is responsible for making sure that all the parts of the status page, or rather the API server, which is providing us with our programmable API or with our API that we wanted, is only accessible by authorized and authenticated users, but only the parts that require this. Then we have the API server layer, which is providing us with our API and is capable and responsible for the interaction with the database layer, which takes care of storing all of our data. So our 2 example implementations again. On the top one, the one we built, we have an Angular web front end, an API server written in Go, and that is protected using DEX and Oathkeeper, as in the policy layer. And we use Postgres for the database. More on that later. Our alternative example implementation would be a command line client as the application layer, because maybe your admins like to keep to their command line environment, or it's something you could use for scripts in an automation setup. A custom auth proxy in the policy layer to authenticate users against your user management system. An API server written in Python, because why not? Python is a nice language. And I think this was an idea we actually had at one point, but did not use. In this example, we used GitHub as our database layer by storing incidents as GitHub issues. I think that was the idea. As I said, this is just an example. We never built this, but this would be possible. And the idea with our replaceability would be that you could take your implementation of a certain layer and simply switch it out for a different one. Let's say you implemented the bottom line application and you have discovered that your custom auth proxy doesn't perform like it used to. Well, throw it out, replace it with our DEX and Oathkeeper solution. Perfectly possible. That is why we wanted it to be replaceable. When we had those concepts, we again sat down and decided that before we start coding, we want to design our API. We went with an API first approach, and to define our API, we created an open API document specification. The Open API specification defines all of our entities, the stuff our data storage stores. It defines the API that we want, so how to access those things stored in the database. All of this is contained in our Open API specification, and we'll have a very quick look at this. So what in our case is the status? Well, we started with components. Components are the things that can suffer an actual incident, an outage, however you want to call it. Those might be low-level components like servers, hypervisors. This might be a high-level view, a high-level component like a service running on said servers. This you might also be tempted to call this a system or a subsystem. Doesn't matter, we ended up with components. Then we have incidents. An incident is the thing that happens to a component. And incidents is the stuff you are working on to resolve them. And it would be useful to be able to describe what you are doing to resolve an incident. So there are incident updates. And there is an impact. Impacts are basically the link between components and incidents. An incident impacts a component. This is how we modeled it, and this is what we ended up with. Graphically again, because we like our pretty pictures, we have the component. A component can, of course, have multiple attributes to describe it, such as a display name, so that in the UI you can actually show a human-readable name to your users. Then we add to that the incidents with their contained incident updates. Again, multiple attributes like what components are affected, when did this incident start, when did it end, in which phase of resolving this issue are we currently. And you have the incident updates to be a bit more descriptive about what is happening. Then we have the impacts. As I said, the impact is there to link components and incidents together. And this is achieved. This is how it is modeled, I should rather say. The actual API specification needed us to include two different lists. We have the impact incident list, which lists all incidents impacting a certain component. And the other way around, we have the impact component list, which for each incident gives you the information which components it impacts. Each incident can impact multiple components. After all, if, let's say, a switch died, this could hit several servers. So it would be useful for incidents to be able to impact multiple components. And of course, every component can be impacted by multiple incidents at the same time. This is the way we modeled it with those lists. When you actually query these information from our API server, you will see that the information is included directly inside of the component or incident. And we did this so to enable you to do just this. We wanted you to be able to either view the system as based on incidents, so you would ask for all incidents and could then see which component it impacts, or you can query all components and then look at the incidents that are affecting said components. We didn't want to put a gun on your breast and say you have to use the view as going from components or incidents. No, this is up to you. So this is the what. What entities are being stored? What does the API look like? What does all of this mean? Wait, that's not a what. That is more like a how. How? Um, Open API specifications, as good as they are for modeling your entities, your API, sadly can't tell you how you are meant to use something. So to alleviate this, we also wrote a standards document. You can find it on the SCS website amongst all the other standard documents. And this will tell you how to use all of those things that we defined in the Open API specification. This will tell you what a severity value, for example, is. This will tell you what IDs look like. All of this information is contained in this standards document. And altogether, you have enough information to build a standard compliant implementation of our status page. Talking about implementation, let's talk a bit about our example implementation. We just need an API server and a front end to write ourselves. As we have seen in our layer overview earlier, the policy layer is being handled by Dex and Oathkeeper. And for data storage, we have Postgres. That means we only need to implement the application layer and the API server layer. And that is what we needed to write. Both should, of course, use our API spec. And by use, I not just mean that it should model compliant interfaces. No, this is one of the nice things about OpenAPI, in case you weren't aware. OpenAPI has a whole bunch of generators. Generators consume your OpenAPI specification, and they put out code that you can immediately use. In our case, that means that for our services, we could throw in our API spec and generate, on the one hand, code for the backend written in Go, and on the other hand, front-end code written not just in TypeScript, but using a special generator, TypeScript, that is already wrapped into Angular services, which is very comfortable. It also means that as long as you as long as you base your projects on the same version of the API, your messages are guaranteed to be compatible with each other. Parity between server and client based on the same API version. Very nice. Now, the API server. I already mentioned we wrote this in Go. Why Go? Well, it's a mature and tested language for writing backend services. We ourselves have had experiences with Go before in other projects. Usually the backends turned out pretty well, I would like to say. It was a pleasant experience. Go is simple to pick up and read. This makes for, or is one of the bases for a good maintainable software. So Go seemed to us like a prudent choice, and I think we can say it was a success. And for the database layer, which the API server needs to communicate with, we chose Postgres because, again, mature project, very well known, easy to find additional developers for. It's also very scalable. We've also used this product before in different projects of different sizes. We have made very good experiences, so we just decided to go with what we knew. On the other side, the web front end. This was written using Angular. Now, some might quite rightly say that choosing a web front end is less of a technical and more of a philosophical question. We ended up deciding on Angular. Why? We could have gone with React, we could have gone with Vue, but Angular is proven technology. It is relatively simple, relatively clean. I've written React before, and having experienced both, even though those React projects have been some time in the past, I think Angular is just a bit cleaner and user-friendlier, possibly in the beginning. In our implementation, we try to put a focus on simplicity. That is both from a user side. We didn't want this to be some overwrought, feature-rich piece of web front end that sees none of its features ever used. Also simplicity as in small footprint, that is both the page shouldn't be in any normal size, and we also wanted to keep dependencies to an acceptable number. I think we have around 20 dependencies, immediate dependencies, I should say. Most of those pulled in automatically by Angular, and the ones we added to this, I think I can count on one hand. And we wanted it to to be developed for, so we packaged the whole project into a dev container. We have been using Visual Studio Code for our programming tasks, which has great dev container integration. We've worked with that in other projects before and found it to be a quite sensible solution to provide easy setup for additional or new development spaces. Great technology. I can honestly and now I've lost the great. Sorry.
Recommend?
Yes, thank you. I can recommend it. It's quite lovely, a piece of technology. And our other components for our policy and policy layer, we made a conscious decision to keep the API server free of any concept of users or authentication or authorization. Because, as I mentioned before, especially if you are a cloud provider, you are likely to have your own user management system, your own user management solution in place. And our status page would be a bit annoying probably to your administrators if they had to perform separate user management tasks in a completely separate system. Now you want to hang this into your existing solution. So we kept all of this out of the API server and defined instead our policy layer where you can implement it how you want. For us, this has been Dex and Oathkeeper, and as our user repository, we used GitHub. The entire SCS project is hosted on GitHub. We have, I guess, an SCS GitHub project on GitHub. Sensible. Everyone who is working on the project is a member there, so this sounds like a good source to authenticate users against. And we are doing just that using OAuth 2, with a little caveat that you need to be a public member of the project. If you're hiding your participation, I'm afraid you're not allowed to log in. Authentication, as mentioned before, is provided using the Dex identity provider, which is querying GitHub using our IDC. And authorization is the user allowed to do this operation is done using Oathkeeper. Again, a nice pretty picture. Again, a high-level overview, this time not separated by layers, but rather we have our user and an admin user at the top. The user tries to perform a read operation on the red front end, that is simply opening it, displaying the current status. This request does not reach the API server directly, rather it gets routed via proxy to Oathkeeper. Oathkeeper then decides, is this a request that needs authentication? In this case, no, and happily hands the request over to the API server, who can fulfill it now. On the other hand, if the admin tries to, let's say, update an existing incident or create a new incident, that is a write operation. Again, it is proxied over Oathkeeper. This time, Oathkeeper determines that this is a protected operation that needs to be performed by an authenticated and authorized user. So Oathkeeper approaches Dex. Dex authenticates the user, in our case against GitHub, returns a token, and Oathkeeper handles then the authorization workflow, and if everything plays out, will hand the request over to the API server, which can fulfill it. Talking about deployments, we are also providing you with a number of deployment examples. We have decided to containerize all applications so that we can then write a Kubernetes deployment using Kustomize. In fact, we provide you with several different deployments. One is a deployment for kind, Kubernetes and Docker formally, that is meant to be a local deployment. This is in fact what I was using for development of the UI. This you can use for such tasks. Have it run locally on one computer, and be certain that whatever you're building will be running in a very, very similar setup in the actual cloud when you are using our kind development environment. There are also a generic template for deployment and a guide for K3S. And there's also, as a working example, our SCS public deployment that is the thing that actually puts the status page on the actual running SCS cluster. It is publicly hosted, you can access it, and because no talk about something that includes UI is complete without having a look at that, this is what you would see if you were to go to our SCS status page right now. As you can see, it is a status page. Quelle surprise. We have by default a 90-day history displayed, so you can see any instance of the last 90 days. We also support maintenance events, that is, incidents that are scheduled for the future. So when you know that in 10 days you are going to perform some kind of maintenance that might impact some of your systems, you can create a maintenance event on our status page, and it will be displayed alongside the normal instance, though still separated so that everyone can see that it is a maintenance event, and your customers can consider themselves informed. This is not the most up-to-date version. We currently still have one pull request in the pipeline that is changing how we are interacting with the status page. Just a very quick view. We have those incident detail views, as they are called, where you can read everything about an incident. You get to that by clicking on the name of an incident in the view you just saw before this one. And our new idea is that instead of having a separate management page where you can create, update, delete incidents and maintenance events, this is now included right in this view. You have this shiny new edit button if you are logged in, and it replaces all of the display fields with actually editable fields where you can add components, remove components, add updates, remove updates, set start and end times, change the face, the name, the description, everything, or even delete the incident. Coming soon to an SES cluster near you, I guess. The end. We are done. Except, of course, for any questions.
Thank you,
Get well soon.
Sebastian. Yeah.
It was a pleasure. I like my incessant babbling. Yes, as he just mentioned, Joshua is capable, though, of answering technical questions concerning the backend or the deployment.
Are there questions? High level or deep dive? That is not the case. So thank you. Thank you very much.